This is the video for special topics on data analytics, and the topic is about collaborative filtering. So we are going to discuss the collaborative filtering, and in this case, there are some subjects that we are going to learn. The first is about the user base nearest neighbor, and then we will learn about the item based nearest neighbor, and more about ratings. For the question, okay, using the below data, what is the possible rating of Charlie on item 4? Okay, so if you see this one, Alice give a bad rating on the item 2, and Alice give a good rating on the item 4. Bob give the good rating on item 1, item 2, item 5, but bad rating on item 4. Meanwhile, Charlie has the item 1 is good, item 3 is bad, and item 5 is good. So, what do you think about the Charlie for item 4? Okay, do you have any idea? Yes, because I know that there is a similarity between Bob and Charlie, not with Alice, because most of the rating here, they are the same, here they are the same, then I can predict that this is bad. Okay, so that's the way usually we do for the prediction. Okay. Now in the collaborative filtering, we want to know more about the strategy, because in the domain of recommender system, collaborative filtering is the most prominent approach to generate recommendation, and it is used by large commercial e-commerce sites. It is well understood, and there are various algorithms and variation exist. And now it is applicable in many domains, for example, books, movies, DVDs, and many other things. So the approach is use the wisdom of crowd. The wisdom of the crowd means we get the rating from the users and we use that rating to recommend the items. So the basic assumption and idea is user give rating to catalog items implicitly or explicitly, and customer who had similar taste in the past will have similar tastes in the future. Okay, so one more time. So customer who had similar tastes in the past will have similar tastes in the future. So that's the assumption using this collaborative filtering. So the input, yeah, we know that the input can be anything, but for the pure collaborative filtering approaches, the input only a matrix given user item ratings. So this is the user, this is the items, and yeah, let's suppose this is the rating. So the rating here is good, yeah, for the thumb, and then this is bad. Okay. So the output will be a numerical, okay, a numerical value prediction indicating to what degree the current user will like or dislike a certain item. So if we just have two, like and dislike, then we can say this is a kind of binary. Okay. But sometimes we can have a numerical. Yeah, if it is binary, maybe it is 0, 1. If it is numerical prediction, it can be 1 until 5, for example. And then after we know the possible numbers or the predicted numbers, so we can select the top and list of recommended items. The basic technique for the collaborative filtering, first we will learn about the user base nearest neighbor. Okay. the keyword is user base, it means we are looking at the user information. Okay, so in the user information, in this case, we have an active user that is Alice. Okay, so we'll assume here Alice, and then there are items that not yet seen by Alice. So in this case, item I not yet seen by Alice, that is the item number 5. So we want to predict what will be the rating of this item 5 given by Alice by looking at the crowd information. Okay. So the method is, first we will find a set of users who like the same items as Alice in the past. So we want to find the users with the same items, and then find a set of users who have rated item I. So we are good on our data set because all of the rating are available. So we just assume that all ratings are available, and then we can use the average of the rating to predict. So if Alice will like item I, so then we will use that average and do this for all items Alice has not seen and recommend the best rated. So the basic assumption and idea is, as I mentioned to you, if users had similar tastes in the past, they will have similar tastes in the future. Okay. And user preferences remain stable and consistent over time. So this is the assumption. Okay, the user preferences will be the same. So it means I do not have any changes on the taste. I don't have any changes on my preference. For example, if I like the comedy movie, then I will always like the comedy movie. Then how if we look at an example? As I show you in the previous slide, we have a database of rating of the current user, Alice, and some other users. So we have this one, user 1, user 2, user 3, user 4, and also Alice. And now we are going to determine whether Alice will like or dislike item 5, which Alice has not yet rated or seen. Okay, so there is no rating on the item 5. Now we need to do the prediction. So the first question, we need to understand how to measure the similarity. Okay, how do we measure the similarity? And then how many neighbors should we consider? And how do we generate a prediction from the neighbors rating? So these three, we will check it, how we can solve it. So the first, we are going to use a popular similarity measure in the user-based collaborative filtering. It is called as the person correlation. Okay, so we already learned from the previous lectures, using the person correlation. Let's say that we have the A and B, they are users, and then we have RAP means the rating of user A for a item P, and then P is a set of items rated by both A and B. So it means we need to make sure that both user A and user B already rate that item. So possibly the similarity values between -1 and 1. Okay, so the lowest one is -1, the highest one is 1. And as we know, for the similarity, the nearby one, it will be the same or the highest similar values. So we use this formula. I think you already know this one. So let's make it with the example. Now we need to calculate the average. Okay. So we need to calculate the average of Alice. So in this case, we know that the 5 plus 3 plus 4 plus 4. So the average is 4. And you can see the user 1, user 2, user 3. So you can also calculate the average. Yeah. So in this case, I can calculate the average. Just this 3 plus 1 plus 2 plus 3. Okay. And then we can get the average is 2.4. Now, because we already have the average of A, this is Alice, and we have the average of user 1. Now we do the person correlation. So we put the RA here, we put the RB here, we put the RA here, we put the RB here. So every of the values here, 5, it is the rating from item 1 minus by the average, and then 3, this is the rating of item 1 user 1 minus by the average of user 1, and so on. So when you put into this formula, you will get the similarity is 0.85. So I think I put the page in duplicate. So this one is the result. So you can see that if it is similarity between Alice and user 1, the similarity value is 0.85. But if it is the similarity between Alice and user 2, it is 0.7. If it is between Alice and user 3, it is 0. And then if it is between Alice and user 4, it is minus 0.9. So you can see this one is very it is far away from Alice, and the user 1 is the most similar to Alice. That's why we can say that, okay, we can try to predict this value based on the information from the user 1 or maybe user 2. Okay. So if we want to select only one, we can select user 1. If we want to select multiple users, we can select user 1 and user 2. So if you look at the visualization, you may see that this is how the Alice compared to the user 1 and compared to the user 4. So Alice is represented in this blue color, and then the user 1, you can see the pattern is similar, but the user 4, the pattern is totally different. So works well in the usual domains. It is compared with the alternative measures. And you can use also the cosine similarity. But in the user-based similarity, usually we use the person correlation. So after we have the similarity, we can predict. Okay. The prediction function, we can use this one. So the prediction of the user A, comma P is the item. So it means we will check the average of the user A, and then sigma of the similarity AB multiplied by this formula and then divided by the sigma. So calculate whether the neighborhood ratings for the unseen item I are higher or lower than their average. So we are going to combine the rating difference and use the similarity A. We use the similarity A as a weight. So the similarity value will be the weight. If it is nearby 1, of course, it is very high. But if it is 0.8, then the rating will be lower. If it is 0.6, of course, it gives you a lower one. So add or subtract the neighbor's bias from the active user average and use this as a prediction. So the example would be something like this one. So let's say I'm considering that the user 1 and user 2 will be the near neighbors. Okay. So the prediction of Alice rating for item 5 based on the ratings of near neighbors, user 1 and user 2. So we are using this formula. So by using this formula, we can get the prediction of the user A given the item P, and you can look at the average of the user 1 is 2.4 and the average of the user 2 is 3.8. So we can just apply the rating from the user Alice is 4, and then we will check the formula here. Formula here means we want to do the multiplication between the similarity. So the similarity is 0.85 between the Alice and user 1, multiply by the rating given by the user 1, this is the rating given by the user 1, which is 3, minus by the average, minus by the average, plus 0.7, which is the similarity between Alice and user 2, multiplied by 5, which is the rating given on the user 2, minus 3.8. So the 3.8 is the average of user 2. And then it will be divided by the total weight or the total similarity. So the total similarity is 0.85 plus 0.7. So we can get the value 4.87 for this rating. Okay. But maybe you will have questions. Why it is in a float with point? Yes, because there are some widths. Okay, there are some widths here. So it is approximately 4.87. So if you have the maximum value is 5, then we can say that, okay, this is near by 5. Then it is a high value. Then we can say that Alice will probably like the items. So, okay, this is the similarity value. So you can use this as the numbers in the formula. Okay, so we already learned how to use the person correlation for the similarity matrix. You can have this learning check and please practice. So suppose we want to predict Alice rating for item 5 based on the ratings of user 1 and user 3. Okay, so what is the predicted rating? So let's look at the user 1 and user 3. So please try, practice. What will be the answer for this one? Okay, we will discuss this one in the class and hope you can do well for this one. Okay, so see you in the class.